Now we're going to talk about graphing cosine, which is very, very similar to graphing sine. There's actually just one key difference that you're going to have to remember. So we talked about these values for sine. I'm going to go through and fill out these tables. In order to get these values, what I'm doing is I'm taking these angles, which are our thetas, and if you plug them into your calculator, if you type in cosine of 0, cosine of 30, cosine of 45, as long as your calculator is in degree mode, it's going to give you these values that I'm writing down. So I'm going to write down 0. The cosine of 0 is 1. Cosine of 30 is approximately 0.866. Cosine of 45 is about 0.707. Cosine of 60 is 0.5. And then cosine of 90 is 0. And now these values are going to kind of repeat themselves, but they're going to be negative. So 0.5, negative 0, 0.707, 0.866, until they get to negative 1. Then we're going to go back up. And then until we get back to 0, and then they're going to go back up again. So if you compare these to the values that we got when we did the sine function, you notice that these are actually the same numbers, and they're even going in the same order. It's just that they're starting in a different spot. So I want to highlight a few of these numbers. I'm going to put a little star next to our quadrantal angles, so 0, 90, 180, 270, and 360. And I'm actually going to also write in what those measurements are in radians, because that's what we're going to be using when we actually graph these. So these values that I'm putting red stars next to, those are the ones that you need to have memorized. So the 1, 0, negative 1, 0, and 1. And those are the main 5 points for cosine that you need to have committed to memory. So what I'm going to do is draw a quick sketch of this graph. This is the parent graph. So I'm going to label my x values. And these are the same ones that I wrote in red on our table to the right. Our maximum and minimum y values are at 1 and negative 1. And now I'm going to plot these points, the ones that I put a red circle around. And I'm going to graph them in blue. So now instead of starting at 0, 0 like sine does, we start at 0, 1, then we go down to 0, down 1, back to 0, and then up 1 again. So our points that I just did in blue kind of look like a V, but when you connect the dots, they should be a curve. And this should look kind of familiar. What I want to show you, I'm not going to actually draw the whole thing, but if I kept going, so I'm going to do a dotted line over here. If I kept going and I had another point here to the left of the x-axis, it would be at negative pi over 2. I'm sorry, to the left of the y-axis. It would be at negative pi over 2. And if you just look at the section from here and you stopped here, it's the sine graph. It is the exact same thing. It's just the sine graph shifted over to the left by pi over 2. So what you should notice about the cosine function is that it's the same thing as the sine function with the phase shift. So the cosine function is the sine function with a phase shift. And I'll even be more specific that it's a phase shift of pi over 2 to the left. Default values for cosine are exactly the same as default values for sine. They're the same thing. So when we talk about default values, we're talking about our parent function, which is y equals cosine x. The domain is all real numbers, because if we kept going left and right, it would go on forever and ever. When we talk about domain, we're more specifically talking about just one cycle of the graph. So a lot of times we say that our domain is from 0 to 2 pi, but either one of those would be acceptable. The range is the same as sine, again, from negative 1 to 1, and you can see that on this graph here. This would be 1 up here, this would be negative 1, that's as far as it goes. Amplitude is also 1, that's the highest and lowest it gets from the midline. Period of one cycle of the cosine graph is 2 pi, and the midline would be at y equals 0. So these are all the standard values, the default values The only time that those things are going to change is if you have different values put into your equation. So really quickly, I want to review what all of these letters do. They actually do the same thing as they did in sine. Your A value affects amplitude, which tells you how much above and below the midline you go. It also tells you if it's negative, that the graph is reflected. Your B value tells how many cycles, the number of cycles between 0 and 2 pi, which you also use to find period. Your H number is phase shift. That tells you how far left and right your graph is moving. And then your last thing here is midline. So your K value is midline. It tells you how far up and down your graph is shifting. We're going to determine several things about each of these functions. What I would like to do is go through and do one feature at a time of all the examples. So the first thing I'm going to focus here on is amplitude. So remember, amplitude is your A number. I'm going to write the equation up here. A cosine B x minus h plus k. So the A number, which is the very first thing in front of cosine, is your amplitude. So for number 1, our amplitude would be 2. It's this number right here. For number 2, our amplitude is 1. And the reason is because there's no number in front of cosine. There is a negative, but that doesn't affect amplitude. The negative actually tells you that this graph is reflected. And then for number 3, the amplitude would be 1/2, because that's the number in front of cosine. The next thing we're going to take a look at is period. Now, one thing I want to emphasize is that period is not equal to your B value. So B value is what you're going to get out of your equation. That's the number that's in between cosine and x. That is not immediately your answer for period. You have to plug it into the formula 2 pi over B to get period. All right, so for number 1, our B value is 6. So to find period, we have to do 2 pi over B, and that reduces to pi over 3. So the period for number 1 would be pi over 3. For number 2, the B number would be in between cosine and x, and there's nothing there. So if there's nothing there, we can assume it's a 1. So that would mean period is 2 pi over 1, or just 2 pi. So if there is no B number, the period is going to be the default period of 2 pi. Number 3, same deal. We have nothing in between cosine and x, so that means period is 2 pi over 1, which is just the default period of 2 pi. Now we have to do translation. So the first thing we're going to talk about is phase shift. Phase shift is when you have an H number. So if you look up here in the top right, this H right here, if you don't have parentheses, that means you don't have a phase shift. So in number 1, I don't have parentheses. That means that there's no phase shift. So I'm going to write none. For number 2, I do have parentheses. And you have to be careful because this sign right here, you have to make sure you go in the opposite direction. So even though it's negative, it's going to be moving the graph to the right by pi over 3. And then for number 3, there are no parentheses, so that means there's no phase shift. And then last but not least, we have to talk about vertical translations, which is represented by this K number, which is also our midline. So I'm going to write midline here. For number 1, there is no K number. That means there's an invisible plus 0 there. So my midline would be plus 0. That also means that there's no vertical shift. For number 2, my K number is 3. So my midline would be y equals 3. And in parentheses, I'm going to write that this would shift our graph up 3. And then last but not least, our midline for number 3 would be negative 5. So y equals negative 5. And because it's negative, this would shift our graph down by 5. Now we're going to go backwards. We're given information about the equation and we have to write it. So I want to remind you of something before we move forward. We talked on the previous slide about how if you want to know period, you have to do 2 pi over b. But if you want to go the opposite direction, if you have the period and you want to find b, it's basically the same formula, but you just switch b and the period. So b is going to equal 2 pi over the period. It's like the same equation, you just divide by whatever you have and it gives you the other thing. So for number 1, we don't actually have to worry about what I just wrote up there for number 1. We have an amplitude of 1. So that's the number that goes in front of cosine, but since it's 1, I don't have to write it. So I'm just going to write cosine of x, and then midline goes at the end of our equation, so I'll just put that -4 there. And that would be your final answer. For number 2, we have 3 things going on. I have a midline at -2. It's reflected, which means I'm going to have a negative in the front. And then it tells me the period is 3 pi. So again, period and b are not the same. I can't just take this 3 pi and put it into my equation. I have to use this thing right up here that I'm putting a green star next to figure out what my b value is. So before I worry about the equation, let's figure out b. So I'm going to do 2 pi divided by period. The pi's cancel each other out, and that leaves me with just 2/3. So that would be my b value. So for my equation, I need the negative for the reflection. B goes in between cosine and x, and then my midline goes at the end. So this would be our final equation for number 2. And then last, number 3, I have to do, again, I have to figure out my b number. I'm given period, that's pi over 4. So I'm going to do 2 pi divided by period. Since I have a fraction in a fraction, I need to take my numerator and multiply by the reciprocal of the denominator. My pi's cancel each other out, and 2 times 4 gives me 8. So my b value here is 8. So my equation, my amplitude would go first, and then I would have cosine of bx, and then my midline goes at the end plus 5. The last thing I want to point out, which we talked about a little bit when we learned sine, is that when you are given either the period or the b number, they should be opposites. And what I mean by that is if you have a small b number, that would translate into a period that's bigger than 2 pi, and vice versa. If you have a large b number, you should have a period that's smaller than 2 pi. So if you look at number 3, your b number is 8. That's a pretty big b number. So that makes sense then that the period is pi over 4, which is smaller than 2 pi. Now we're going to determine some information just by looking at a graph. So the first thing we need to do is find midline and amplitude. And those two things, sometimes you can just look at the graph and see it. Sometimes you want to use the equation. So I'm going to show you for number 1 how you can just look at it. And number 2 is a little bit trickier, so I'll show you the equations on that one. So for number 1, let's take a look at midline. To me, it looks just like it cuts right through here at 2. And once you draw it in, it's a little bit easier to see that, yeah, that looks right, so the midline, it must be 2. For amplitude, you're looking to see the highest and the lowest points from the midline, and each of them are 3 boxes up, 3 boxes down, so I can see amplitude is 3. Number of cycles between 0 and 2 pi. This one, we're looking for 1 full cycle of the cosine function. So you have to kind of switch gears. We've been looking for the sine graph. And remember that the sine graph looks like this, where it starts at 0, and then you have a hill and a valley, and then it stops back at 0. So this is what the sine graph looks like, which is what we've been doing up until this point. But now recall that when we looked at the cosine graph, it starts here at 1, makes a big U, and then finishes back at 1. So we're looking for something different. So you have to kind of think about that. So here we go. That's our starting point. If I went down and back up to the same point and stopped, that would be 1 full cycle. And if you look down here, if you follow this all the way down to the x-axis, that happens at 2 pi. So what that means is that there is 1 full cycle between 0 and 2 pi. It also tells me that the period is 2 pi, since that's where 1 cycle stopped. If you couldn't see that from the graph, or you just didn't trust yourself, remember that this number here, the number of cycles between 0 and 2 pi, that is actually your b number. So if you wanted to use that formula, 2 pi over b, it would be 2 pi over 1, which is still 2 pi. All right, now last but not least, we have our equation. So we have amplitude that goes first, and then I have cosine of bx, but since b is 1, I'm not going to put anything there. And then our midline is 2, so I'm going to write plus 2. Now for number 2, I said I was going to show you those formulas to figure out midline and amplitude. So in order to do this, we need to have our top and our bottom y values. So over here, my top y value looks like 3.5. My bottom y value looks like negative 0.5. So the formula for midline is to take your top value plus your bottom value, which is negative 0.5, and divide by 2, which would give you 3 divided by 2, or 1.5. So y equals 1.5 would be your midline. And you can draw that in and kind of make sure that everything looks right. And then for amplitude, it's the same formula as midline, but now we're going to subtract. So it's going to be 3.5 minus negative 0.5 over 2, which is 4 over 2, or just plain 2. So what that tells you is from your midline, you're going up 2 boxes and down 2 boxes. All right, now number of cycles from 0 to 2 pi. 2 pi is way over here on the right side of the graph. So let's go ahead and trace all of these cycles and see how many there are. So remember that each cycle is going to be like a U shape. So there's 1. This would be 2. There's 3. And then I think we can fit 1 more. So that tells me that there are 4 cycles, 4 complete cycles of the cosine graph between 0 and 2 pi. And remember that now 4 is our B number. Now there's 2 ways you can figure out period. The first way is you can take your B number and you can do 2 pi over B. So 2 over 4 reduces to 1/2, so period would be pi over 2. The other way you can see the period is by looking at where this first light blue cycle stops, which is right here. And then if you look down to the x-axis, this right here represents the period. So again, pi over 2. Now the last thing is the equation. So I have y equals, amplitude is 2. And then I have cosine bx, so 4x. And then plus 1.5 for my midline. All right, last example of this type. We're going to find midline and amplitude. I can see the midline pretty easily on this one. It looks like it's just right at 0. So I'm going to put in my, my midline here so you can kind of see it. It's a green line. So that y equals 0. And then my amplitude, if I go up and down from my midline, it's only going up half of a box and down half of a box. So my amplitude is 1/2, or you could say 0.5. Number of cycles from 0 to 2 pi is a little bit tricky because here's 2 pi and that's not a full cycle yet. So it's going to be a fraction. So in this case, I think it's easier to figure out what one cycle looks like. And then from there, we can divide using our little formula. So this one, when you look at it, I think it actually looks more like a sine graph than a cosine graph. And what's going on here is that your cosine graph is actually reflected. So I'm starting here, and instead of it being a U, it's kind of like a hill. So it's the cosine graph, it's that U, but it's upside down now. So I can see now that this graph stops at 8 pi. So that tells me period is 8 pi. And now to figure out my B value, I'm going to use that 2 pi over the period formula. So if I do 2 pi over 8 pi, pi's cancel, and then 2 over 8 reduces to 1 over 4. So there's a quarter of a cycle between 0 and 2 pi. Last thing is the equation, and I want to put a little star up here. I mentioned earlier that this is reflected, and I know that because it's making a hill instead of a valley. So I have to make sure that when I do my equation, I have to make sure that there's a negative in front. Now the amplitude is 1/2, so I'm going to write negative 1/2, and then I have cosine bx, and then my midline is 0, so I don't have to write plus 0, I can just be done. The only thing I want to mention is that when you have a fraction b value, there are 2 ways you can write it. The first way is how I have it written already. You could also write it as x over 4. So both of those would be correct answers if you wrote them down, but I just want you to be aware that if it was a multiple choice type situation and you got the first way, but the only choice was the second way, that they do mean the same thing. All right, so now we're going to graph. This is going to seem very similar to sine, and that's because it is very similar to sine. The only difference are going to be those y values. So one thing I want to mention before we get started is there are 2 things that can change your x values. Normally your x values are the ones that you use with your parent function, which is pi over 2, pi, 3 pi over 2, and 2 pi. The 2 things that can change that is if you have a different b value, which changes the period of your graph, or if you have an h value, which tells you that you have a phase shift. So if either of these two numbers or these two letters are present in your equation, it is going to change your normal x values. So if you take a look at number 1 here, your b value would be here in between cosine and x, so that means that there is no, it's not a different b value. Right now it's equal to 1. And I also don't see parentheses, so that means I have no h value as well. So what that means is that my standard x values, my normal x values, I can automatically put those onto my graph. The only thing that's changing here is this 2, which is going to change the amplitude of the graph. So instead of going up and down 1, it's going to go up and down 2. So I'm going to label that on my y-axis, and then we'll be set to go. So now in order to finish my graph here, normally when we were talking about sine, we were always starting at 0. Now we're talking about cosine. So normally cosine starts at 1, but because our amplitude is 2, we're going to multiply that by 2, and it's going to start here. And then we're going to kind of make a V shape with our points. So it starts at 2, back to our midline or our 0, down to midline, and then up 2. So I have kind of that V shape with my orange points, and then I'm going to make sure when I connect the dots that I connect them in a nice curve to make that cosine U. Now for zeros, this is asking me where it crosses the x-axis. So I see 2 places where it's crossing the x-axis, and I have to write them as ordered pairs. So the first one is at pi over 2, 0, and the second one is at 3 pi over 2, 0. For domain, technically the answer would be all real numbers, but because we were only asked to graph this one cycle, I'm going to write that this domain starts at 0 and stops at 2 pi, and I'm using square brackets because there are actually points there, so those values are included. And then range is talking about how high and low the graph is going. So the lowest it gets is -2, the highest it gets is +2, and again square brackets because we actually have points at those values. One thing I want to make sure I point out is that the reason we have to worry about brackets versus parentheses for domain and range is because those represent intervals. They're talking about where something starts and stops. We do not have to worry about that with zeros because those represent points. Ordered pairs always have parentheses. All right, so the first thing I want to check for is if there is a b value or an h value. A b value would be between cosine and x, so there's no change in our b value. And then the h value would only be present if we had parentheses. So I see no parentheses, that means we have no h value. So I can automatically put my 4 tick marks here, and I can label my normal x values. All right. Next thing we're going to do is midline. This graph has a midline of y equals 1, and I'm getting that from this k number here. So I'm going to go ahead and fill this out, y equals 1. And what I'm going to do now is I'm going to put in that midline here at 1. So I'm going to just do a dotted line because it's not actually a part of my graph, but I'm using it as kind of a guide. Okay, so I have my midline at 1. Now I can see my amplitude is 3. So from my midline, I have to be able to go up 3 and down 3. So from my midline, if I go up 3, that leaves me at 4. And if I go down 3, that puts me at -2. So I know that I can accommodate all of my y values. And then the last thing we have to be careful about is this negative here, which tells me that my graph is going to be reflected. So we just have to be careful. Normally, when we start a cosine function, we would be up whatever our amplitude is from our midline, but now because it's reflected, we're going to be down that many. So since our amplitude is 3, we're going to start down 3 from the midline, then back to the midline, now up 3, back to midline, and down 3. So now instead of our points making a V, now they make kind of like a triangle or a pyramid shape. But again, when you connect the dots, make sure that you connect it with a smooth curve. It shouldn't look like a pyramid. It should be like an upside down, or it should look like a bell almost. All right, now we already answered amplitude. We said that the amplitude was 3. The only thing we haven't talked about is period. Now over here in orange, I have written, it says no b value. That's kind of not true. There is a b value. The b value is actually 1. So if I wanted to find period, I would do 2 pi divided by b, which is 1. So the period is just 2 pi. And again, you could have probably answered that without doing this work. If your b value doesn't change, your period will be the standard one, which is 2 pi. You could have also looked at your equation, at your graph and seen that it started at 0 and stopped at 2 pi. This problem has a phase shift because I have these parentheses. So what this tells me, since it's plus, is that it's going to go the opposite direction. So it's actually going to go left pi over 2. So since normally we start at 0, if I move to the left by pi over 2, my new starting point is actually going to be here at negative pi over 2. So the graph is going to start here where I put that purple negative pi over 2. The next thing we need to do is figure out where the rest of our tick marks go. So the first thing we're going to do is figure out what is the period of this graph. So period is 2 pi over b. In this equation, b is 1. Since there's nothing there, you assume it's a 1. So period is the standard 2 pi. Now I'm going to take that standard period and I'm going to divide it into 4 equal parts. And that's going to tell me what to add to my starting point to get my remaining 4 tick marks. So if I reduce 2 pi over 4, I get pi over 2. So what I'm going to be doing is adding pi over 2, or really what we're going to think is we're adding 1/2 to our starting point, and we're going to keep adding it over and over again until I have a total of 5 tick marks. So the first thing I'm going to do is take my negative 1/2 and I'm going to add 1/2. If I do that, it's going to give me 0. So what that tells me is that my second tick mark is actually going to be right there on 0. Now to find my next tick mark, I take 0 and I add 1/2. I'm always adding 1/2 because of this thing right here. If I do 0 plus 1/2, that gives me 1/2. So my next tick mark is going to be pi over 2. Now, I said I needed 5 points total, 5 tick marks total. I have 3, so I only have to do this process 2 more times so that I have my 5 total tick marks. Now I'm going to take this 1/2 and add 1/2 to it. If you add 1/2 plus 1/2, it gives you 1. So this is going to be pi. And then for my last one, I take 1 plus 1/2, which is 1.5, but we're going to write it as 3/2, so 3 pi over 2. So it actually, you might notice they are the normal x values, it's just that we don't make it all the way to 2 pi because we started a little bit to the left. Now, nothing else is going on in this graph, meaning there's no amplitude change, there's no reflection, and there's no midline change. So from here, my amplitude is just going to be 1, so I can go up 1 and down 1 on the y-axis. And then to plot my points, I have to start at negative pi over 2, but they're going to be my regular 1, 0, negative 1, 0, 1. So I'm still going to get that V shape that we should see. So 1, 0, negative 1, 0, and 1. And then I'm going to connect them with this curve so that it looks like an upside down bell. Maximums and minimums are asking you for the highest and lowest points on the graph. So there are actually 2 maximums, this one here and this one here. They're both maximums because they are both just as high as the other one. So I'm going to write down 2 points. The first one is at negative pi over 2, 1. And this other one is at 3 pi over 2, 1. And then for minimums, this one's asking me for the lowest point. So there's only one minimum, and that happens at pi over 2, negative 1. Last example, we have a b number. B here equals 3. So what that means is that we will have a period change. So I cannot automatically put in my normal x values on the x-axis. So first thing we're going to do is figure out period. So I do that by finding 2 pi over b. I can't simplify anything, so that is the period of this graph, 2 pi over 3. So what I can do, since I know that there's no phase shift, I know that I'm going to have 4 tick marks. My 5th point will be at 0. And I know that my 4th one will stop here at 2 pi over 3. Now to figure out what the other tick marks should be labeled, we're going to take period, which is 2 pi over 3, and we're going to divide by 4. And remember, we do that because I have 4 sections. I have 5 points, but they divide the number line into 4 sections, and I need to know what length each of those sections will be. So if I want to divide by 4, I have to take 2 pi over 3 and multiply by the reciprocal of 4, which is 1/4. This gives me 2 pi over 12, and then if I reduce, it gives me pi over 6. So each time that I go to the next tick mark, I'm going to be adding pi over 6. So if I take 0 and I add pi over 6, it's going to give me pi over 6. Now if I take pi over 6 and I add pi over 6, it's going to give me pi over 3 when you reduce. And so just so that you know what I'm doing, you can do this in your calculator. You can do 1/6 plus 1/6 and it will tell you that the answer is 1/3. And then I'm going to add pi over 6 again, and it's going to give me pi over 2. So again, in your calculator, you're going to take 1/3 plus 1/6, and it's going to give you 1/2. And then what I like to do is add pi over 6 one more time, so take 1/2 plus 1/6, and double check that you actually get 2/3. That's how you can kind of double check that you know you have the right tick marks going on. All right, next thing. We do have a midline. That's the only other change here. This is your midline here at y equals -2. So I'm going to draw that in here, put a dotted line at -2. It's always good to put your midline in before you do anything else having to do with amplitude, because your amplitude goes off of your midline. So if you do your amplitude first, you're going to have to change it anyway once you put in your midline. So midline is at y equals -2. Now the amplitude of this graph is 1, since there's nothing in front of cosine. So that means from my midline, I'm going to have to go up 1 and down 1. So I'm already able to go up 1, I've got that tick mark, but I need to put one more in here so that I can go down 1 as well. So now I'm going to plot my points. From my midline, cosine always starts however far your amplitude is above the midline. So since amplitude is 1, we're going to start 1 above the midline. Then you go back to midline, down 1, midline, up 1. So we're making that V shape again that we've been making over and over again. And then when you connect the dots, you want to connect them in a nice curve. Now the only thing we haven't answered, even though we talked about it, is amplitude. So I'm going to fill that in, that the amplitude here is 1.